We are reacting a weak base with a strong acid, represented in solution as H3O+. So the first reaction of concern is the base reacting with our hydronium ion to produce the conjugate acid and water. Looking at the initial quantities of ammonia, our weak base, we have 4.0, and we've added 1.0 millimoles of our hydronium ion. So that's essentially the limiting reagent. It runs out, but in the process consumes a millimole of ammonia, and we've produced 1 millimole of our conjugate acid. So in solution, we have some amount of a weak base, and we have its conjugate acid, i.e. buffer. The follow-up, or the equilibrium reaction, can be represented by our ammonia reacting with water in an equilibrium situation to produce its conjugate acid and hydroxide. We can get the numerical value for pH from Henderson-Hasselbalch. We want to be careful to use the Ka to get the pKa, because likely we're going to be given the Kb of the relevant base. And as always, the ratio of the base to the acid in moles is going to be the same as the ratio of the concentrations, since they are in the same solution.